Hi guys, my name is Nur Aida Shaira. I will present to you about introduction. As for introduction, you guys need to know about what is marine clay. Marine clay is a type of soil that largely exists in lowland and offshore areas. It is a sensitive soil. In our project, we identify how to improve marine clay stability for construction in Malaysia. Okay, now let's see what are the problems that happen in our country due to construction on marine clay. If you guys want to know more about our project, don't skip this video.
For the case study that we choose for this project is marine clay soil. Marine clay soil. It is a very common type of soil in Malaysia. Why do I say it is a common type of soil in Malaysia? Because Malaysia, we have a tropical climate and its geological location. Okay, what are the problems being encountered by marine clay soil? First, its low strength. The strength of marine clay soil can be measured by using Unified Compressive Strength, or also known as UCS. It is a test that measures the max vertical load of stress before failure on the soil. So, the typical marine clay soil has the strength of 25 to 50 kilopascal, which is very low. It is important for us to know the strength of the soil to be used as foundation before we start the construction. The second problem is its compressibility. Compressibility is when there is a change in volume of the soil. It is mostly caused by two main factors, which is expulsion of water from the soil and the particle rearrangement of the soil, or rather known as soil fabric rearrangement. This is a very serious problem that will be caused on the site. First, it will cause settlement and it will make your structure, the superstructure, fail. Marine clay soil is actually very strong when it is dry, but it is hard for us to expose water from marine clay soil. And the third problem that we encountered is its low permeability and seepage. Low permeability. What is meant by low permeability? Marine clay soil has the ability to absorb water, and when it absorbs water, it is in a slurry form. In its slurry form, its strength is very negligible. It cannot even withstand its own self-weight. The moisture content in marine clay soil are usually higher than its liquid limit. When it is higher than its liquid limit, we can know that the properties of the soil are mostly the same with liquid. So, it is hard for us to drain water from marine clay soil because of its small pore space. That is what is meant by low permeability.
So, the first method to do the stabilization is by using rice husk ashes. Rice husk ashes, also known as RHA. RHA is a byproduct of wastes from the produce or the progress of processing paddy. After the process, there will be 22% of waste left over as RHA, the rice husk ashes. Prasad et al. In 2015 already proved that RHA is a very useful method that can be used in the stabilization of soft soil or marine clay. It has been proved in his research that it can help to strengthen a few parameters of soil properties such as liquid limit, plastic limit, CBR value, and so on. Besides, it is proved that 20% of the RHA mixed up with the soil is the best ratio to do the stabilization. After that, Koteswara Rao at 2012 also proved that RHA has a little cementitious value, but when it reacts with water, it will have chemical reaction that it will increase the cementitious value and release cementitious compound that help to do the stabilization. RHA is very easy to be found in Malaysia since Malaysia is a country that produces a lot of paddy every year. Besides very easy to be found, it is also very cheap to be bought since it is only the waste from the product of rice.
The second application is we call as bottom ash BA or fly ash FA. This material are byproduct from electric power plant. Waste material are disposed and generally have no economical value. BA is physically coarse, porous, glassy, granular, grayish, and incombustible material that are collected from the bottom furnaces that burn coal. Whereas FA or fly ashes is grey in color and dust-like material. According to Juhaizat in 2014, it is found that they have pozzolanic material or pozzolanic properties which make it possible to replace cement in deep soil mixing. On top of that, other ingredient has been added such as lime or cement to promote better pozzolanic reaction between the additive and clay. Yao Shou in 2003 also revealed that the fly ashes or FA exhibit a likelihood of pozzolanic reaction due to its chemical composition and physical characteristic. FA or fly ashes as an admixture in the stabilization of a soft marine clay result in stabilized sample with an improved strength more than 75 times that of the untreated clay. Other soil characteristics are plasticity, particle density, and compaction properties were also monitored. The results show that by using this admixture, the strength development can be increased over time. This proves that this admixture can be promising ingredient in deep soil mixing. By doing so, a high performance clay cement column can be produced in the near future. Thank you.
The third method to stabilize the marine clay is by using chemical biomass silica and rubber chips mixture. Rubber chips is most suitable to be used in the construction project according to its lightweight material, low density, high durability, high thermal insulation, and least cost as the fill materials. According to the research from Marto in 2015, it's about rubber chips mixture as the stabilizing agent for improving the characteristic of marine clay from two engineering perspectives, for the strength and the compressibility. The results show the treated sample had higher unconfined compression strength compared to untreated sample. The strength of marine clay increased when the amount of the chemical biomass silica increased. Other than that, weight ratio reduced in value when the chemical rubber chips mixture was added to marine clay. From the study, it can be concluded that the mixture of chemical rubber chips with 8% chemical biomass silica plus 1% of rubber chip is more effectively improve the characteristic of marine clay.
They have two major techniques for stabilization and solidification treatment for soil: in situ and ex situ. Ex situ involve method applied that involve excavation of soil and its transfer to another location, either on or off the site, for mixing with stabilization agent. So for in situ involve mixing with binder or reagent into the soil at the place where the soil found, or original place of soil, without involved transfer and excavation procedure. From the finding and observation, the stable method is in situ stabilization using the in situ bucket mixing or excavation mixing, because of the method and procedure implementation, and the equipment involved does not too complicated, and also not involving the complex system and the high technology equipment. This method is the simplest form of mixing and can be used to mechanically mix reagent and other additive material with soil. This technique offers cost-effective and schedule efficiency solution for this method. Equipment and machineries that involved in this technique or method is a bucket mixing, generally carried out with the excavator and the standard excavation bucket or specialty or modified bucket, so that shallow mixing application may be complete and more efficient with the bulldozer or front loaders. In terms of staff or staffing, it required 4 to 5 person, include the mixing excavator operator, mixing excavator labor, supervisor, QC, and the engineering staff. Labor requirement is very different on the project scale or project requirement. In terms of treatment depth, this technique or method are limited to 2.5 meter or 8 feet as a uniform mixing, but when beyond that limit, it will not be effective more. So, but some cases bucket mixing may extend it to 4.5 to 6.2 meters. But if the soil stabilized or treatment depth are exceeding the limit that have stated before, the other technique or method must be considered to be used, such as the auger mixing that can go deeper application greater than 4.6 meter or 15 feet.
As conclusion, in Malaysia, normally at coastal area it is marine clay soil, which are the title of this case study, that has the most problematic soil with very poor soil properties. To do the stabilization, among all the methods that we have already stated before, rice husk ashes, also known as RHA, is the most suitable method to be used. It is because RHA is very cheap and very easy to be found in Malaysia. Besides, it has already proved that it can help to improve the soil properties, such as increasing the strength, the compaction value, liquid limit, plastic limit, CPR value, and so on. Besides, it is already proved that 20% of rice ashes is needed only to be added into the soil to reach its optimal ratio to do the stabilization. Other than that, just like what I said before, it is very cheap, very easy to be found, since Malaysia is a country that produces a large amount of paddy. Lastly, it is very eco-friendly and it is an organic material that will not harm the environment. That's all. Thank you.